Imagine an objecting through vast expanses of space for billions of years, crossing unimaginable distances and finally making a visit to our cosmic neighborhood. But not from our solar system, from an entirely different region of the galaxy that formed much, much earlier than the Sun itself. And that's the remarkable story of this newly discovered 3E Atlas. The third ever discovered interstellar comet that since its discovery surprised quite a lot of astronomers, mostly because of its unique characteristics and its somewhat bizarre orbit. And so hello for person, this is Anton. In this video we're going to be discussing some of the recent updates about this new exciting comet, focusing on some of the most recent scientific observations and some of the more recent somewhat unusual discoveries made by several scientific teams and by using several different telescopes in just the last 6 weeks. And that's because this is of course a somewhat recent discovery. This object was only seen on July 1, 2025 by NASA-funded Asteroid Terrestrial Impact Last Alert System, or ATLAS for short. But as we've discussed before in some of the videos in the description, it essentially became confirmed as an interstellar object within approximately 24 hours. And that's of course because of its somewhat fast velocity. Compared to the previously discovered Oumuamua and comet Borisov, this object was moving much, much faster. It seemed to contain an unbound hyperbolic path with the excess velocity of 58 km per second, which was much higher than 26 km and 32 km per second for Oumuamua and Borisov. But even the trajectory here was way more extreme. This was a very hyperbolic orbit with the eccentricity of 6.13, essentially making the path almost appear straight instead of being curved. And as this object approaches the Sun, its velocity is going to increase even more, reaching the maximum speed of 68 km per second at perihelion. Although unfortunately at this time we're not going to be able to see it because it's going to be behind the Sun. And once it starts leaving the solar system, its velocity is gradually going to slow down, but it's still going to remain one of the fastest objects in the solar system. And while here, as we've discussed previously, one of the more bizarre discoveries was of course in regards to the trajectory and specifically where it came from and its vertical velocity. Right now, what we know about it is that it seems to have come from the southern celestial hemisphere, the direction opposite to the direction of the Sun's movement relative to local stars. But more importantly, it was moving upward through the galactic plane with a vertical velocity of 18.5 km per second relative to the Sun. And this high vertical velocity is very unusual compared to nearby stars and of course other interstellar objects. In essence, suggesting that 3E Atlas seems to follow a tilted orbit around the Milky Way, possibly resembling something like this. And more importantly, this places it inside the thick disk population, the region in a Milky Way galaxy that consists of predominantly very old stars that are much, much older than the Sun. And so in a study we mentioned previously, Matthew Hopkins and the collaborators from the United Kingdom estimated that this object seems to be at least 7.6 to maybe even 14 billion years old with approximately 70% confidence. So this is probably the oldest comet we've ever seen and much older than the solar system, which formed 4.6 billion years ago. But I guess what's even more surprising is that for this whole time, this comet was very likely just drifting through space, not interacting with anything, with the Sun basically being the first star it's seen in a very long time. And though right now it's impossible to trace it back to the specific parent star, mostly because this happened billions and billions of years ago, and its speed and trajectory very likely changed because of various gravitational encounters, right now, this presents us with the best chance to potentially study ancient star systems by indirectly observing a piece of that star system right here in our neighborhood. Furthermore, based on the observations of the emissions and the observations of the Cometary tail, specifically water-rich composition that was observed almost right away here, researchers concluded that this object formed beyond the snow line of the star system, where we usually expect water to condense into solid ice right away. And that's kind of how we expect most comets to form in most star systems. But eventually this object was gravitationally ejected from the home system, possibly through some kind of a close encounter with a giant planet similar to Jupiter. But it's really that cometary activity that's the most exciting feature and the feature that's going to be analyzed the most in order to discover what this object is made out of. And we already have a few surprises in regards to its chemical composition. First of all, this was confirmed to be a comet almost right away because it just appeared to be very fuzzy, much fuzzier than typical background stars. And that's of course a direct indication that this is a cometary object, with an object containing what's known as a coma, a cloud of gas and icy dust ejected from the surface because of the heating from the sun. And to here, observations by NASA's TESS revealed that 3I Atlas was already exhibiting cometary activity as early as May 7, 2025, approximately 2 months before its official discovery. And at this time, it was much farther away than Jupiter. And this early activity is particularly noteworthy because temperatures at such distances are usually too cold for water ice to sublimate, which of course suggests that the initial activity was likely driven by the sublimation of much more volatile ices, something other than water. And here the coma itself is also quite substantial. It appears slightly elliptical and appears to be constantly expanding and expanding quite quickly. And here, observations from Vera Rubin Observatory show that the diameter grew from 13,000 kilometers on June 21 to nearly 19,000 kilometers on July 2, with Gran Telescopio Canarias eventually measuring it to be 26,000 kilometers in diameter, or twice as big as Earth just a few weeks after, essentially suggesting that this cometary object grew extremely fast and expelled a lot of material very quickly. But one of the most significant discoveries here is of course water. And here water ice was detected between July 5 and 14 of 2025. And several separate telescopes were able to confirm the existence of water, observing both water vapor and hydroxide ions. And this was already visible approximately 3.5 astronomical units away from the Sun, which is technically a little bit unusual for comets because normally we don't expect detectable amounts of water vapor and even hydroxides at such large distances because of very cold temperatures. And though right now there is no exact explanation, there's at least one potential proposition here. Scientists believe that this water vapor and hydroxides detected by these telescopes seem to be produced by sublimation of water ice grains which must have been ejected from the nucleus by outgassing of something much more volatile, maybe carbon dioxide, maybe carbon monoxide, or basically the comet started to evaporate much earlier because of something else on the surface and those water particles got ejected as a result. And here the active surface area for this entire comet seems to be very large. Approximately 20% of the surface area seems to be evaporating, which is much higher, or approximately 4 times higher than what we usually see in a typical comet in the solar system. Normally it's about 3 to 5% of the entire surface. Here it's over 20. With this increased activity explained by the hypothesis that this comet has never seen another star for at least several billion years, suggesting that it basically just has a huge reservoir of very pristine materials that are finally evaporating because Sun is the first star they've ever seen. But in terms of other volatile elements, initial spectroscopic observations from early July of 2025 seem to have discovered no evidence of gas emissions containing cyanides, dicarbons, tricarbons, or oxygen. And here for astronomers, this was maybe just a little bit surprising because the absence of cyanogen radicals, also known as CNS, which usually have a very low sublimation point and are typically the first signals detected in comets, seems to be just a little bit unusual. And so even though these substances are expected to exist on this comet, so far they have not been detected anywhere. And here we have at least 2 potential explanations. First one suggests some kind of a thick layer of irradiated organic compounds that seems to suppress volatile outgassing from the surface of this comet. The other one is the low metallicity origins of this comet, or essentially the fact that it came from some really ancient stars containing very low amounts of heavier elements, suggesting that this unusual comet is just carbon poor and extremely enriched in water compared to anything in the solar system. And right now that second explanation seems to make the most sense. Basically this comet is just super ancient and so just seems to contain a lot more primitive stuff. Likewise here, the coma appears to be just a little bit reddish in visible wavelengths. And that's actually similar to what's known as D-type asteroids in the solar system, but also similar to active solar system comets and even previously discovered comet Borisov, all of which contained reddish complex organic compounds that must have been created through the exposure to cosmic radiation. This is, by the way, the same color and the same reason Pluto is red as well. But one of the bigger surprises in the last few weeks was this: the sun-facing dust bloom, or basically a tail that's pointing toward the sun and toward the direction of motion. And so this is different from a typical tail pointing away from the sun. And though this is quite rare for comets, it is not impossible. Here, this bloom is believed to be emitted from the heated sunlit surface of the nucleus where the ice sublimation occurs much faster. And this has been observed in other distant comets as well, which tend to preferentially eject dust from their sunlit sides. But additionally, the Hubble Space Telescope was able to discover another tail. A faint tail pointing eastwards away from the Sun, which is a much more common cometary feature usually formed by the solar radiation pressure blowing away small dust particles away from the comet. And so, in other words, this comet seems to have quite a few tails. But based on some of the more recent observations,